Hey guys, Noah here with Learn Meta-Analysis, and in this video we're going to be talking about moderator analysis, which you may see referred to as subgroup analysis. So we're going to focus primarily on categorical moderators here. So by the end of this video, I'm hoping that you'll be able to identify key elements of conducting a moderator analysis, specifically with categorical moderators. I also want you to properly interpret a categorical moderator analysis. So I think the best way to go about this is to really take a few minutes and think about some of the key ideas. So before we get started, over here on the right, you're going to see a categorical moderator analysis output from using metaphor in R. So let's first talk about what we're actually looking for when we do this. So you can see over here on the right, we have the test of moderators highlighted in green, and that's what test we're going to be interested in primarily right now for this discussion anyway. That's what we're interested in when we're using metaphor. If you're using comprehensive meta-analysis or some other software programs, you may see a similar analysis that's called Q-between. Essentially what we're doing or what we're looking for right now is if there are significant differences between levels of the moderator. And what I mean by that is, let's look at the model result. We can see we have an intercept, which we're going to come back to here in a minute, but you can also see we have grades K through 5, not stated, other, and post-secondary. So in this case, what we're interested in is we want to know if the effect size, for example, grades K through 5, is significantly different than the one for, let's say, post-secondary. That's what this test of moderators is looking for. That's what we want to know when we run a moderator analysis. Essentially, are there significant differences between these levels of the moderator? So again, we're looking at the test of moderators in this metaphor output, which is highlighted in green, and importantly, this is the model with the intercept. I say this because you need to be really careful, because metaphor has two different tests labeled test of moderators. The model with the intercept is equivalent to Q-between in CMA. Now, if this is significant, like I said, then that means there are significant differences between levels of your moderator. If it is not, regardless of if the individual effect sizes in your table are significant or not, the levels are not significantly different from one another. Okay, so let's talk next about residual heterogeneity. This is something that I really don't see discussed a lot in the educational sciences. Like when I read meta-analyses in education, I don't see this mentioned a lot, and I'm really not sure why. So let's talk about what it is. So if this is significant, there's unexplained variance that the moderator does not fully explain. So this seems important, right? This is something that helps provide some context to our model. But again, like I said, I don't typically see this reported. I'm hoping this is something that will change in the future. So this is something you should be aware of, and metaphor gives this to you very easily. So if it is not significant, that means that the moderator explains most of the variation in your model. Okay, so let's go through an example. As you can see over here on the right, we have similar output, right? We have a test of moderators, we have residual heterogeneity, and we have our intercept. Those are all highlighted. So the first thing that I want to draw your attention to is that this model does contain the intercept. And this is what we want to use when we're looking at the test of moderators to better understand if there are significant differences between level of the moderator. In this case, we can see that P is 0.36. That means there are not statistically significant differences between level of the moderator in this example. Okay, so now let's check out the residual heterogeneity. In this case, it is significant. This means that there is unexplained variance that the moderator doesn't explain. But if you are familiar with meta-analyses, you're probably looking at these estimates and the labels here in the table, and you're probably thinking that this doesn't necessarily look like tables that you're used to seeing in studies you read. Specifically, you probably are not used to seeing the intercept when we report these ANOVA-like models rather than a regression type model. So what do we do? Well, if you're using metaphor in R, then what we can do is run the model again and remove the intercept. What this will do is it'll create our table just like we're used to seeing. So you can see the intercept is now removed, and we now have estimates for all of the levels instead of assigning one of the levels as an intercept. Here, note that the test of moderators is significant. However, this is not the same test. I'll say that again. This is not the same test. When you remove the intercept, it runs a different test as the test of moderators. So if you're looking for significant differences between levels, you need to be looking at the one with the intercept included. Now, this is a little bit different than the residual heterogeneity, which in this case is identical between the two models. Okay, so let's summarize. First and foremost, Remember the difference between there being differences between levels of a moderator and a significant effect size for a specific level of a moderator. Well, they're of course not the same thing, but their importance is different. So let's think about this for a moment. Let's use this example at the bottom of the page. It says we have grades 6 through 8 and we have grades K through 5. In this case, we can see from the data that's here, neither one is significant, but we don't know if they're statistically different from each other either. So let's say that they are. Let's say we have a significant test for moderators when we include the intercept, and we know that these are statistically different from one another. What does that actually mean? This is the really important piece of the puzzle that's really easy to overlook. Okay, we need to include context when we're interpreting this information. So let's back up a bit and put a little more context to this study. Let's say we're investigating in our meta-analysis, the overarching question is, what is the impact of virtual characters on learning? Okay, so what this means is we're comparing virtual character to no virtual character group. Okay, that's our framework. Now we want to know what moderates that effect, so we're looking at the participant's grade level. If we say that this was statistically significant between levels, then we know, okay, the answer for grades 6 through 8 is not necessarily the same as the answer for grades K through 5. Let's pretend that that's a significant difference on both of those effect sizes. Does that mean that a virtual character is more effective for grades 6 through 8 than it is for learners in grades K through 5? Sort of. It is important to remember that these effect sizes are referring to virtual character versus no virtual character groups. So what this really means is that students in grades 6 through 8 learned more when using a virtual character compared to no character than when students in K through 5 learned with a virtual character compared to no character. So it's really, these are kind of nuanced explanations, but they're really important when you start to think about how you explain your results, because it's really easy to overgeneralize these. So please remember that you need to consider the context of your overall analysis and make sure that you're speaking to these things appropriately. So again, to kind of reiterate, you need to know if there's significant differences between levels of your moderator. If there are, you then want to know which effect sizes are significant and which aren't. And we want to actually consider the context of our analysis when we are interpreting this data. So that's pretty much everything that I have to say about categorical moderator analysis. It's really not that complex. The main complexity comes into play if you are using R and you're running tests in Metaphor. And I say it's complex only because there are two different tests labeled, the test of moderators. And if you're used to reading in a ANOVA-like table rather than a regression type table, then you need to run a separate analysis to actually get that ANOVA type table. So hopefully this has given you a nice overview of this process. And honestly, I find the best way to learn these things is just to go through and practice. And my open book has some examples and some example data sets for you. So if you want to practice running these types of analysis in R, my open book will be able to walk you through that process, and there will be links to that throughout the course. But that said, that's pretty much everything I have to say about categorical moderator analysis in Metaphor and R. So with that, I will leave you guys, and I look forward to seeing you in the next video. Thank you.